Hello everyone, today we'll talk about computational thinking week 1. So first thing is flowcharts. Let's take one example. Suppose you are going for a vacation, okay, you are going to Dubai. So whenever you go for a vacation, you have to plan your vacation, okay? So there are some steps which you have to follow. Like first thing which you have to do all the bookings, right? So the first step which you will do is booking. Then after booking, what you will do? You have to do packing. Okay. After packing, you have to go to the airport. Airport. After airport, you will reach Dubai. In Dubai, so in Dubai, you will do some activities. So this is like activity one, which you will do. Then after doing this activity, you will visit hotel one. Okay, after Hotel 1, you will go and do some activities. Again, after activities, you will go to the Hotel 2. Okay, now then you will go to airport and then you will be back home. So here you can see the first thing which you have to do is booking. After booking, you have to pack. After packing, you have to go to the airport. Then you have to then you will be in Dubai. You will do this activity. Then you will visit this hotel. You will do this activity. You will visit this hotel. Then you will come. Then you will go to the airport and then you will be back home. Okay, so here you can see the flow of information. So flow chart shows you the flow of information. Okay, so this is a kind of layout or the or we can do some plannings with the flow chart. Okay, so for vacation this is our flow chart. Let's look at the definition now. Flowchart is a graphical representation of an algorithm. Algorithm, what is algorithm? Algorithm is step-by-step instructions to perform a specific task. Okay. Programmers use flowchart as a planning tool to solve a problem. It makes use of symbols which are connected among them to indicate the flow of information and processing. The process of drawing a flowchart for an algorithm is also known as flowcharting. So when we draw a flowchart, we have to use all these elements. So the first one is terminal. Okay, so we use terminal to start a flowchart. In the starting, we will write start. Okay, and at the end you have to write stop or you can also write end in it. Okay, so at the starting and the ending we use this block. Okay, in the same way we use this block to declare any variable or to take input from your user or display output. Okay, now this block, processing block, this block is used to perform any arithmetic operations. If you want to perform addition, if you want to perform subtraction, multiplication, division, you will use this block. This decision block is used when you have to make any decision. So in short, when you have to use iteration or you have to do any filtering. Okay, so you will use this block. And this flow line, this is the simple line and it connects all these boxes like this. Okay, and this line, this flow line also tells us about the flow of information. Okay, so here we have one more example for flowchart. Here I want, so I'm taking two numbers from the user and I want to display the number which is greater. So my starting my flowchart by writing start in terminal block, then I'm using this input output block. So in this first input box, I am taking one input as num1. I'm taking one number from my user. So suppose the user gave 4 in this number. Now I'm taking another input and that is number 2. So I will give another number that is 3. Okay. Now this is decision making block. Here it will take decision that if num1 is greater than num2. So is it true? If it is true, we'll move in this direction. Okay. You can see the flow line. Okay. And if it is false, we will move this side. So for now, num1 is greater than num2. So this block will make a decision and it will flow this information to this direction, and here the num1 will be get displayed. Okay, here it is use we again using output block, input output block. Okay, display num1, so it will display number 1, and this block, this is connector block. Okay, so we basically use this block in very complex flowcharts when we have very complex problems to solve. Okay, for now we don't have to use this block. So, and here you can see stop in terminal block. Okay, so this is how we use flowchart. And so the next thing is data sets. What are data sets? Data sets are the records. For example, in any shop, shopkeepers keep record of their stock, they keep records of their shopping bills, they keep record of their customers. In colleges, they keep records of mark sheets, they keep records of their teachers, they keep records of their students. So all these records in themselves are data sets. So mark sheets are the data sets, shopping bills are the data sets, and records of teacher is a data set, records of students is a data set. So data sets are simply records. Okay, the next thing is iteration. So let's take one example for iteration. In this example, we have this robot and we have this dining table over here, and 6 people are sitting on this dining table. Now this robot has to serve everybody. The first thing which it has to do is it has to distribute plates to everyone on the dining table. So to do the same, you have to give some instructions to your robot. Okay, so to distribute the plates, to distribute the plate, our robot will read the first instruction, go to the kitchen and get a plate. It will go to the kitchen, get one plate, give to the first person. Then it will read again the second instruction, go to the kitchen and get the plate. It will go and get another plate. Then it will, in the same way, it will read all the 6 instructions and it will give plates to all the 6 people on the dining table. So here we have to write one same instruction for 6 times to perform this task. Okay. So here this is the place where iteration comes in picture. Iteration also called as loops. Okay. So let's see how do we use loops or iteration to write this code only one time and do the same task. Let's see how this iteration works. So the first thing is while. This is a loop. Okay, we have so many kind of loops: while loop, for loop, do while loop. Okay, so for now we are using while loop and we have to give some condition over here. So here I'm giving the condition is there is more people on the table. So this iteration will work when there is more people on the table. Okay, so a robot will come and visit this instruction. It will read while there is more people on the table. So it can see, if this robot see, yes, there are so many people right now, so it will go to the kitchen and get a plate and it will give to one person. Okay, now it will read this instruction again. There is more people on the table, yes, there are more people on the table. Go to the kitchen and get the plate. It will get a plate and give to the second person. Now it will again read the same instruction, and yes, there are more people left without plate, so it will go to the kitchen and get the more plate. Now it will go to the instruction again. It will read there is more people on the table, yes, there are three people left, so it will go to the kitchen, get one more plate. In the same way it will repeat it for 6 times, and when it will come back to the while after giving the sixth plate, it will again read the instruction, there is more people on the table. No, there are no more people on this table. So this instruction will be and over here. Okay, so this is how iteration works. Here we are using this piece of instruction only one time and it is repeating 6 times. So when we have to repeat one instruction for so many times, we simply use loops or iterations. Okay. So let's take one example to understand iteration or loops. So here we have to find total math marks of all students from marksheet data set. Okay. So in this marksheet data set, I have So in this mark sheet data set, I have, suppose I have three cards, okay, three marks cards. I have three mark sheets with me, okay, and this is pile one. Pile one. In pile one, I have three cards, card one, card two, card three, and this is pile two, okay, and in this pile two is empty for now. This is empty. So here, as you can see, we have a flow chart here. Okay, so we start with this terminal block start. Then we have one variable called sum and its initial value is 0, as I have written here also. And now we have our decision block over here. Okay, and this is where we are using iteration. And what is the condition in this? When there is more cards in pile 1. Okay, if there is more cards in pile 1, then it will take this flow line, yes 1, or otherwise if there are no more cards in pile 1, it will take no flow line. Okay, so for now we have three cards already in our pile 1. Okay, so it will take this flow line, yes 1, and the next instruction is pick a card from pile 1. Okay, we have pick up this card from pile 1, and the second instruction is move X to pile 2. Okay, now we have to move this card to pile 2. Now I have keep this card 1 over here, and the next instruction is add cards math score to sum. Now suppose it has 50 marks in maths, this is student, so I will add 50 over here in this sum. Okay, okay, let me change the So I will add these 50 marks over here in the sum. Okay. Now the sum total will be 50. Then now it we will take this flow line and will come here on the iteration again. So what is the condition? More cards in pile 1. Do we have more cards? Yes, we have two more cards. So now pick a card from pile 1. I will take this card 2 and move X card to pile 2. Now I will move this card over here, card 2, and suppose it has 60 marks in maths. So add cards maths score to sum. So now this 60 marks I will add to sum. Now I will get the total sum 110. Okay. Now we'll take the same flow line and we are here on the iteration again. Is there are more cards in pile 1? Yes, we do have. We have card 3. Okay. Pick a card. We have already picked it. Move to the pile 2 and I have moved this card to the pile 2, card 3, and suppose it has 50 marks in the maths. Okay, so here add cards maths score to sum. Now we'll add 50 marks over here, so the sum total will be 160. So now we'll add now we'll take this total sum and that is 160. So now we'll take the same flow line over here and we'll see more cards in pile 1. Do we have more cards? No. There are no cards. So we'll take this no flow line and there is a AND. So here we have the sum total of maths marks of all the students. So this is how we use iteration. Okay. Let's have a look at the definition of iteration. Going through a sequence of objects and performing the same operation on each object. For example, counting. So the next thing is variable. Okay. So let's take one more example to understand the variables. So variables are the containers basically. Suppose you have a glass. Okay. So in the morning, you can fill this glass with the hot water and you can drink. In the evening, you can fill this same glass with the milk and you can drink it. And next morning you can fill the same glass with the juice and drink it. So you are using the same glass and storing different kind of drinks. So here you are storing hot water, here you are storing milk, here you are storing juice. Okay, in the same way we have our variables. Okay, so this container has a name as glass and you can put whatever value you want to put. You can put whatever drink you want to put inside it, right? In the same way we have variables are also containers and we have to give some names to the containers. Suppose I'm giving the name as sum. Okay, this is the name of my variable and this is my variable, this big box. And now I can put whatever value I can put. I can store whatever value I want to store. So, suppose I'm storing 0 in it. Now after some time I want to store 2 inside it. Now after some time if I want to store 4, I can remove this 2 from here and I can write 4 over here. Okay, so the name will be same, the container will be same, but the value inside it we can change this value. That's why it is variable, it is varying. Okay, so it doesn't have any constant value inside it. This value can be changed. So I have this variable and I'm giving it a name as best friend. Okay, and I want to keep my best friend name inside this variable. Okay, now so at one time we have only one best friend. Okay, so today I have my best friend, his name is Sam. Okay, but after 2 months I have changed my best friend from Sam to Ria. Okay, now my best friend is Ria. Now again I have changed my best friend and now my best friend is Ananya. Okay, now, so I have the same container, I have the same name for my variable, but the value inside it is keep changing, right? So my best friend is keep changing, and now I can store whatever value I want to store in this variable. Okay, this is how variable works. So in computational thinking, you will see so many variables. Some of them are sum, count, max, minimum, and they have initial value as. So what is initial value? Initial value is this first value which we give, which we store in our variable. Okay, so I'm storing 0 as my first value. In count also I'm using 0, and in max also my initial value is 0. In minimum my initial value is 100. So it also has one logic behind it. So this is all about variables for now. Let's take a look at the definition of variable. An entity whose value keeps changing as the computation goes on. Okay, so the next thing is filtration. Okay, filtering. So let's take an example for filtering. So now, suppose you want to do shopping, okay, online shopping. So here I'm on Amazon and I want to buy a phone. Okay, so I will search for a mobile phone here. Mobile phone. So now I can see so many results over here. When I have searched for mobile phone, I have iPhones, I have Redmi, and Oppo, Samsung. So I have all the brands over here. So when we shop, no, we know what brand we are looking for. So here comes filtering. So what I will do, I'll come here and I can see there is a brand and I have filter for it. So I can choose my brand from here. So suppose I want a phone, OnePlus brand. Okay. So I will click on OnePlus, and as I've clicked on OnePlus, I can see all the results. In all the results, I have the phone of OnePlus. Okay, all the phones are of OnePlus over here. Okay, now I can use other filters also. So I have so many filters over here. So I have filter for RAM, internal memory. So suppose I want 16 GB as internal memory in my phone, so I will choose this one. And yes, again, so I whatever phone I will be seeing here, it will be the brand, its brand will be OnePlus, and its internal memory will be 16 GB. So here, so this is how filtering works. Okay, in computational thinking also we have the same logic. We are filtering things. Okay, so this is filtration. This is filtering. So this is how filtering works. Let's take one example in computational thinking. So here I want to calculate the sum of boys maths marks. So in class we have everyone, like we have girls also, we have boys also, but here I want only boys maths marks. Okay, so we are starting it with the sum. So this is the variable, okay, sum, and initial value is 0. Here we have iteration. While pile 1 has more cards, then pick up a card from pile 1, move x to pile 2. Okay, if so, this is where we are using filtration. This is filtration. Okay, this is iteration, this is variable. Okay, and here we are using filtration. What is the filter? If x dot gender is equals to m, like if the gender at that card is male, then only you have to perform this task. Otherwise you don't have to perform any task. If it is a girl, if it is G, you are not supposed to do anything. Okay, so we'll suppose in pile 1 I have these 4 cards with me. Okay, 4 marks card I have. 1, this is male, this is male, female, this is male. Okay, now in pile 2 I don't have any card for now, and this is my sum, and its value is 0 for now. Okay, let me remove all these lines from here. Okay, and now let's start with our process. So the sum is 0. Okay, now we'll start from iteration. While pile 1 has more cards, yes, a pile has so many cards. This is pile 1, card 1, card 2, card 3, card 4. Okay, so pick a card from pile 1. Suppose I'm picking this card. Okay, I have picked it up, and now move X to pile 2. I'm moving this card over here in pile 2, M1. Okay, now what is the next thing? If X gender is equals to M, is the gender M? Yes, it is M. So what I have to do, I have to sum is equals to sum plus, so the maths marks of this male, I have to add these marks to the sum. Okay, so suppose it has 50 marks. This boy has 50 marks in maths, so I will add 50 marks over here. Okay, and the sum total will be 50. Okay, now done with the iteration, we will come back to our while, and we'll see while pile 1 has more cards. Yes, we do have more cards. Pick a card from pick a card from pile 1. We have picked this card. Move it to the pile 2. Okay, we have moved it now, and this boy has 40 marks in maths. Okay, so now we have moved it to pile 2. Now we have to check if the gender on that card is M. Yes, it is M. So what we will do, we have to add maths marks to the sum. So I will add 40 marks over here. So the sum will be 90 now. Okay. Now we'll come back to the iteration, and it is saying while pile 1 has more cards. Yes, we do have more cards. Pick a card from pile 1. Okay, let's pick one card and move X to pile 2. Let's move this card to pile 2. Okay, and it has 50 marks in maths. Okay, this girl has 50 marks. And now if gender is equals to M, is gender M? No, it is G. So we are not going to do this task. We just uh, get out from this filter. Okay, and we'll come back to the iteration. If pile 1 has more cards, yes, it has one more card over here. Pick a card from pile 1. We'll pick this card, and we'll move it to the pile 2, card 4, and this person has like 40 marks in maths. Okay, so if gender is equals to M, yes, gender is M, then add sum, add its maths marks to the sum. So I will add these 40 marks over here, and the sum total will be 130. Okay, and now I got the total maths marks of all the boys in the class. Okay, so this is how iteration and filtration works. Let's take a look at the definition of filtering, and it is to take out specific type of data from entire data set. Okay, so thank you so much guys for listening, and I'll see you in the next session. Thank you.